Stock market bubbles, technology hype trains, and exciting new innovations. These are the things that cause the very worst impulses in organizations. Organizations who want to triple down on Taylorism like it never went away, who want to measure every line of code same as it ever was, and who want to cite this all as some kind of productivity progress. Gen AI is a stock market bubble, a technology hype train, and real, genuinely exciting innovation all at the same time. And of course, that means vendors are falling over themselves to measure developer productivity again, even though activity is not connected to system-level outcomes, even though that's where success really lives. So why do we all need to remind ourselves about Goodhart's law? And why is it that AI usage metrics are so much less valuable than the accelerate metrics of 2018? Hello, and welcome to the channel. If you haven't been here before, or if you haven't subscribed yet, now's the time to do so. That way you can stay up to date with all of the cool stuff that's happening here. I'm Steve Smith, I'm Cornish, and I'm the Global Head of Modernization and Platforms at Equal Experts. I'll be your host for today. I'm afraid Dave Farley isn't available. He's lost a bet to me, again, so he's gone outside to teach some rockabilly penguins how to do ballroom dancing, just in time for a show I'm putting on. Great personal expense. Let's start with a quick lesson. An activity metric measures behaviors. It's easy to measure and it's low value. An output metric measures deliverables. It's easy-ish to measure and it's of some value. An outcome metric measures system changes. It's hard to measure and it has a very high information value. And a bit of history. Measuring software development has been a tricky perennial topic for decades and it's played an integral part of my own career. I still remember Martin Fowler's article in 2003 saying we can't measure productivity. I remember sitting around in my team discussing it and realizing Martin had put words to what we'd all felt for a long time. Martin's article was true for a very long time until Dr. Nicole Forsgren came along. Early on in my career, when I was a tech lead, I was often also the build script person as a leading indicator of my future career in continuous delivery. As the build script monkey, I would often work on metrics tools, something like Sonar. Doesn't really matter which tool you're thinking of, they're all pretty much the same. A giant bucket of activity metrics, all of which will be kind of interesting, some of which will be a bit useful, most of which you would turn off. You could squeeze some value out of these kind of tools. For example, I introduced unit test ratcheting for Copatura into the LMAX CI/CD pipeline in 2008, where we gradually increased the minimum threshold for unit test coverage to nudge the developers to do more TDD over time, and I fell foul of my own test more than once. And at some point I woke up and I realized that these activity metrics and output metrics weren't very useful at all. They weren't tied to value stream outcomes, they offered limited data, and they could be easily gamed. The state of DevOps reports in the 2010s were genuinely different. Dr. Nicole Forsgren and her collaborators looked at technology outcomes in terms of deployment frequency, deployment lead time, rework rate, change failure rate, and time to restore. They didn't look at individual productivity or activity counters or story points or tool usage. They focused on teams, socio-technical behaviors, and business success. While working for Equal Experts, I implemented the State of DevOps Reports measures in an organization with 60 teams and around 300 microservices. Jez Humble and Dave encouraged me to write a book about my experiences, and that became my Measuring Continuous Delivery book, which is still on LeanPub today. Meanwhile, the State of DevOps Reports became DORA, and Dr. Nicole Forsgren published the Accelerate book. This applied statistical validation, cluster analysis, causal modeling, and much more to years of survey data to build and validate a predictive model of organizational performance. It was a high watermark for measuring software delivery. In the foreword, Martin Fowler said the DORA methodology had overcome his skepticism, and Accelerate provided rare, rigorous scientific evidence for how to improve software delivery. I've seen and contributed to many implementations of the Accelerate metrics over the years. I've not yet seen in the wild Dr. Forsgren's subsequent work after Accelerate, and I hope to do so one day. Okay, now let's bring Gen AI into the mix. Gen AI has privacy risks, security vulnerabilities, environmental costs, and it increases the concentration of power amongst a few large technology companies. And it is reshaping the world in ways that are amazing and horrifying depending on how you look at it. Maybe it's both at the same time. This includes in software development, where I have seen GenAI achieve absolute marvels. GenAI makes coding visibly faster and more automatable, so organizations are naturally looking to measure developer productivity like never before. There's a backward slide in industry from outcome metrics back into activity and output metrics. That's because they're easier to implement, and that means that they are easier to gain. It's important to remember Goodhart's law. When a measure becomes a target, it ceases to be a good measure. Another way of thinking about that is people change how they behave based on how they're measured. If you measure AI prompting in teams, don't be surprised if AI prompt count increases. If you measure the percentage of AI-generated code in a codebase, don't be surprised if the number of classes and methods in a codebase goes up. Or if you measure AI costs, don't be surprised if AI prompt count goes down, but AI prompt size goes up. To illustrate the mad dash that GenAI is causing towards developer productivity, I thought I'd look at the AI-assisted engineering Q4 2025 report by DX. DX is a vendor that sells a developer intelligence platform that I've not personally used. I have heard good things about it. Please remember there are other vendors out there. This isn't some arbitrary takedown of DX out of the blue sky. It's a deliberate takedown of weak inference. This is just one example of a consistent pattern in industry over the past year. My beef isn't with DX. It's with software vendors in general selling AI usage as some kind of nirvana, as if the last 20 years of hard lessons learned had never really happened. The report itself from DX is really interesting. The sample size is good. It's at the level of the individual developer. They looked at 135,000 developers from around 400 companies of different sizes in different sectors, in different regions, over a 3.5-month period. And there's a little bit of detail in the survey about methodologies used, which is good to see. But I only see sample volume. I don't see if it's random sampling, if it's self-selected, if it's intentionally stratified, if it's weight adjusted. So in the report's findings, there's no way I can know if this sample of developers is really representative of industry.
Let me pause there and say thank you to our sponsors. We're extremely fortunate to be sponsored here by Equal Experts, Transfic, and Octopus Deploy. Equal Experts is a multinational consultancy built on applying the ideas and techniques that we talk about here to build great software for their clients. All of these companies offer products and services, though, that are very well aligned with the topics that we discuss on this channel every week. So if you're looking for excellence in continuous delivery and software engineering, do click on their links in the description below and check them out.
We'll look at 4 headlines from the report. The first headline is, industry-wide AI adoption is now over 90%. ... It's a core part of engineering strategy. This is an activity metric. So that means it's easy to measure and it has a low information value. I have 2 problems with this headline. First of all, 90% of developers showing usage of AI coding assistants at some point every 3.5 months is not the same thing as 90% of companies adopting AI. Come on now. Second, developer usage of a tool doesn't imply engineering strategy. Strategy is policy, governance, SDLC composition, and much more. Tool interaction is not strategic integration. Headline 2 is, developers save an average of 3.6 hours per week with AI coding tools. This is an activity metric again. The measurement method is admirably documented as self-reported time savings, which is a very weak construct. It depends on memory, counterfactual reasoning, and subjective attribution, and it's easily gamed. Beware Goodhart's law. I know a developer who's a good friend of mine who once received an award at a company because their software development estimates were so accurate. Once they'd received their prize, they confessed, I just said what they wanted to hear. I can easily imagine what this developer's reported AI savings would be, at least 5 minutes higher per week than everybody else. Without linking this measure of hours saved to an outcome like improvements in lead time, this is perception. It's not system performance. Headline 3 is 22% of code is AI authored. This is another activity metric. Again, it's easy to implement and there's a low information value. DX acknowledge it's hard to measure AI authored code accurately, as of 2025 at least. That's a nice admission to see, and I do think tooling will improve here. Their definition, though, of AI authored code is really problematic. code generated by AI that was merged without major human rewrites or modifications. That's subjective at least. What counts as a major change here? Refactoring? Rewriting half a method? Splitting a class in two? Two developers with identical behaviors could give two very different percentages here. And this data is self-reported again. Goodhart's law strikes again. Developers have to remember which changes involved AI, judge how much editing they did, and decide how good they want to look in terms of AI-authored code. And the fourth headline is my absolute favorite. Daily AI users ship 60% more pull requests than non-users of AI. This is an output metric, so it's a sum-ish value and it's a bit hard to implement. Let's see some quotes. One of the most common questions we hear is whether AI adoption is actually helping developers to ship more code. That is a common question, isn't it? My answer would be slightly different to DX. I would just say a better question would be whether AI adoption is actually helping teams to deliver outcomes faster and more reliably. Would you like to collaborate together on finding an answer to that question? The next quote here is, there is a correlation between frequency of AI usage and pull request throughput. I have two complaints here. First, there's no mention of whether this is a statistically significant correlation. The Accelerate metrics carefully distinguished correlation from causation with validated constructs and modeled predictors. To me at least, this report just looks like a descriptive analysis. Second, who cares about pull request throughput? Except for those people actually measured on it, don't get me wrong. Pull request throughput is not as important as you think. It's not a unit of delivery. It's not a unit of developer productivity. A developer could merge 100 pull requests in a day, and there could still only be one deploy a month because there's a central end-to-end testing team with lots of manual regression tests. Alternatively, a developer could merge 0 pull requests a day, and there might be 10 deploys to end users each day because the team is practicing trunk-based development and everyone makes very small mainline commits every 5 minutes, and it all chunks up to 10 deploys a day. A quick reminder here, if you really need it, that trunk-based development is a much better fit for continuous delivery than pull requests. They can work with CD, but it's easy to be led astray. The Accelerate book or any continuous delivery literature from the last 20 years will explain why that is. Pull request throughput will be very noisy. That's what code commits are. They're noisy. More pull requests could just mean the developer's going too fast because they know they're being measured on pull request throughput, and Goodhart's law is struck again. That means they've abandoned unit testing. They're just coding, so there's more defect fixing when it goes wrong, there's more security patching when it goes wrong, there's more rework going into that code that never happened before. This is exactly why the Accelerate book looked at developer throughput and reliability together. The final quote on daily AI users shipping 60% more pull requests is, "It's still possible this doesn't lead to better business results." Well, yes, obviously, because this is an output metric, not an outcome. Number of merged artifacts per developer per week is not speed. It tells you nothing about deployment throughput, nothing about service reliability. It's not causal, it's not system level, it's not predictive of technology performance, it's not predictive of business success, which the Accelerate metrics do predict in a statistically significant way. The report also has an AI measurement framework with buckets of AI usage metrics and a look at lots of American technology companies, all of whom have their own giant buckets of AI usage metrics. To be fair, some do cram in some or all of the Accelerate metrics, which is nice to see. But you don't measure technology success or business performance this way. You can try to understand AI adoption separately and follow a tried and tested path for measuring technology performance. Two things can be true at once. Okay, so what should you do instead of all of this madness? First of all, you need to recognize that the AI age is encouraging companies to triple down on Taylorism and measure developer productivity like never before. You need to remember that a team is the unit of delivery, not an individual. Do your own critical thinking for yourself. Don't listen to vendors. Don't listen to me. Remember that tool-accelerated activity does not equate to real business value. Read the Accelerate book and the modern software engineering book and implement them in your organization. That's all you need. I can wait. Okay, good. Now that's done. Look at your Accelerate metrics. If your deployment throughput, service reliability, and technical quality numbers are all trending in the right direction, congratulations, your technology outcomes are where they need to be. Next, ladder up those outcomes and calculate your time to value and your total cost of ownership across all teams. If both of those metrics are improving together, congratulations, that is awesome. Now ladder up those metrics into contextual business outcomes that matter most for your organization. For a retailer, that might be customer lifetime value, it might be profitability. It really does depend on your company. If those business outcomes are improving, if profitability shows an uptick, then wow, you're really looking good. And you might want to know if AI usage is, has, or will play a part in all of this. So follow the advice in the Accelerate book. Measure your technology capabilities as your leading indicators of success. Look to see if test-driven development is increasing, or if architectures are becoming more loosely coupled, or if continuous integration is becoming more stable. And implement a couple of AI usage activity metrics. See if there's a correlation between AI usage and capability improvement. But be very clear with yourself and with everyone else that these are activity metrics that mean little on their own, and correlation is not causation. Next time I'm here, I'll cover another engineering topic, but Dave has to make those rockabilly penguins do some ballroom dancing first. If they can't do the foxtrot in strict 4/4 time, I will be forced to mark them down. Thanks for watching.